differentiate a polynomial, the general rule is we multiply by the power and we reduce the power by 1. So if y is equal to x to the n, the differential is nx to the n minus 1. We could extend this if the polynomial is multiplied by a constant a. We do exactly the same thing. We multiply by the power and we reduce the power by 1. So if y is equal to ax to the n, then the differential is an x to the n minus 1. Extending slightly further, if the polynomial has two terms, then the differential is the sum of the differential of these two terms. We'll now take a look at a lot of examples. You may want to pause the video and try a lot of them yourself. So if y equals x cubed, multiply by the power and reduce the power by 1. In this case again, multiply through by minus 3 and reduce the power so it goes to minus 4. So our differential is minus 15x to the minus 4. In this case, we write the expression in index form first as 6x to the minus 2. Then we multiply through by the new power and reduce the power by 1. So now we have a sum of two terms. We differentiate each term separately and we add the resulting differentials. In this case, we need to write the fraction as two separate fractions. And we can use the rules of indices to simplify. So we're differentiating x cubed plus x. So reducing the power by 1 gives us x squared, and we needed to have multiplied through by the 3 first. So we have 3x squared and the differential of x is 1. Again, split the fraction into two separate fractions. So we need to differentiate 3x to the 4 over 2 plus 5x over 2. Multiply through by the power and reduce the power by 1. Gives a differential of 12x cubed over 2 plus 5 over 2. And we could of course just simplify this a little. In this case, we need to multiply out the brackets first and use the rules of indices to simplify the expression. So we're differentiating x to the 7 minus 7x to the 5 plus 2x squared minus 14. So the differential is 7x to the 6 minus 35x to the 4 plus 4x, and when we differentiate minus 14 we have 0. If we have a root, we need to use index form. So to differentiate x to the half, multiply through by half and reduce the power by 1. In this case we can write 2x to the minus a half, and we multiply through by minus half, and we reduce the power by 1 again. This gives us minus 1 over x to the 3 over 2. Again, splitting the fraction into two separate fractions. And using the rules of indices, we need to differentiate x cubed plus x to the minus 3 over 2. So the differential is 3x squared minus 3 over 2 times by x to the minus 5 over 2. Which we could write as 3x squared minus 3 over 2x to the 5 over 2.